Hey guys, welcome back to the channel, and tonight we will be working on this 2015 Mercedes. It's a C300. It actually has I think it's a 2-liter 4-cylinder turbo. It was brought to me by a customer that had it at multiple other shops, and finally I think one of those shops referred them to come over here to see what the problem was, because I believe they have been chasing some sort of issue. As far as what that issue is, customers tells me that it's like a loss of power or low power or hesitation while just driving along, and I think after it warms up is one of the things that he told me. At least for me, I experienced it not cold, but I had to drive it for a while to get it to act up. Now, this isn't going to be anything too crazy, but I did want to bring you guys along to kind of show you how I verify what the issue was, because I myself was almost going to start questioning things, but that is why I end up picking up the camera and did the test that I did in order to make sure that I make the right call. And like always, first things first, I scanned the vehicle and was concerned with just the engine computer, and it was pretty straightforward as far as trouble code related to the symptom. And that was my first sign as to why is it really here. Now, just to kind of show you, again, this is a setup that we've messed around with quite a few here in the shop. There's some common failures that do go on with this particular setup. So, with the symptom, the customer was explaining the engine setup that the vehicle has, and what the customer ended up handing me, I almost immediately started to basically make a hypothesis as to what had been going on. I'll admit, I was, again, just kind of jumping ship and assuming that this was going to need timing. My thought was that they saw timing codes and were throwing all the cam and crank sensors at it and still had an issue. If you can tell, there is sealer all on that front cover, and it's hard to tell, but there is some along the side for the valve cover. When I saw that, and then the way it started, which most of the time when these have timing codes, they'll have an extended crank, and then they'll start run and drive. They usually won't have a issue or a drivability issue after it's running and driving. It's usually at startup, it's an extended crank, and it'll have timing codes. So, seeing that has been work there, it has no extended crank, but then there's a plethora of sensors, which these seem to be cam sensors. So these two have been replaced. Both the factory used ones are in these boxes, and these, I guess, are supposed to be crankshaft sensors, but maybe they were just guessing and not getting the correct one, or not able to do them, or I have no idea. So I still haven't looked up any crankshaft sensor, see which style or type it is or whatnot. But as far as the trouble code, again, almost self-explanatory, and one I've not seen myself here either. So right here, position sensor 1 for the crankshaft has a sporadic malfunction. Again, has a sporadic malfunction. There is an internal fault. So PO 339339 and the 04 on that on the end. So I mean, most 99% of the shops out there will see that code and throw a crankshaft sensor at it. So to me, it's why is it here, and what's really going on. If, in my thoughts, thinking maybe a crankshaft sensor had been installed and still not fixed. So because it's such a straightforward, basically code description and possible situation, meaning quote unquote simply just a sensor, I wanted to just double check and verify, and I wanted to drive the car, get it to act up while monitoring the crankshaft sensor signal and both cam sensor signals. And so that's what I've got hooked up. And unfortunately, on camera, I was not able to get it to act up while driving, while filming, and show you the actual hiccup point. But if you just trust me, believe me, after it's hot, I had to let it idle for maybe 40 minutes sitting here, just idling, because I started it cold, went driving, nothing. Let it idle for a while, went driving, and I got it to act up about 3-4 times down one road. And I luckily at least was monitoring, so I can show you the data. I didn't get it on film, but I'll show you what I found and how we can make an accurate call. So just a quick shot of my connections. Again, crank, intake cam, exhaust cam. And what I will do is show you how it cranks to let you know that it's not the typical timing code issue, extended crank situation. So it starts up right away. And yes, of course, it's got every light, every message, so on and so forth. But we are only asked to check the drivability issue. So again, I'll get you over to the scope data and show you what we got. Okay, so here we got the scope capture. This is not one of when it was faulted, but it's one that I wanted to do as a kind of a base or known good to be able to explain as to what I am wanting to do. To start off, the channels are, so the blue is the crankshaft, red is intake, and then green is going to be exhaust cam. And let's zoom in here just to get a look at what the signals look like. And there you go. So pretty straightforward. Again, square waves coming in. I actually did compare for timing, and it is within the same parameters as the other waveform, but yet again we do not have any timing code, so we know that wasn't going to be an issue. Again, we are concentrating based off trouble code on this signal here, our crankshaft signal. During the situation where we are experiencing the problem, I'll call it the hiccup, because it feels like almost like you hit a wall, keep going, hit a wall, keep going, and it's just random. As soon as it gets hot, it'll do it intermittently, and at times it'll go almost like a limp mode. But so just based off that, again, I wanted to concentrate on the crankshaft sensor signal. And what I wanted to do with it is, if you notice, we've got an additional channel here, and it's the pink. So this is what Pico has, and it's called math channels. You can basically create these channels by setting parameters, and with crankshaft sensor signals, you can make a channel that will basically display and show you the actual physical speed, movement, and rate, and acceleration and deceleration of the crankshaft when you apply it to the crankshaft sensor signal. So this is one that I wanted to show you. So obviously we're all, it looks like solid blobs because of our time base, but this is what I wanted to show you. So the vehicle was idling, so it's at a steady state. I turned the vehicle off. We dropped because the crankshaft's not spinning. It was off for a while. Then I cranked it and started up. And so it starts, comes down, and I revved it. So I snap throttle, and it comes down, and then I turned it off. So by me doing those things, we can't see that in this signal portion right here. It's just, a square wave. But with the math channel, we can see what the square wave is doing as far as speed. And so this is kind of my base and known good, and I wanted to show you guys that. And so this is what I'm going to use to try to identify or see if there's an issue with the actual signal, because this is based and built and created off of the signal. And this is the waveform of when it actually acted up on me during the test drive. Now I've got the other two channels turned off, but I'll show you quick that, there they are. So just for better visualization, I will have them turned off, but I, again, was doing the testing and driving while monitoring all of them. And this is what I came up with. As I keep saying, I am interested in that. And if we just graph the crank sensor, it's really not something truly that stands out, jumps out, or is truly identifiable. If you look at it in this whole big graphed out portion, and you won't be able to pick out, even though you experienced the problem, it's just very hard to try to find an issue and try to, thumb through this whole waveform and all those segments of teeth and so on and so forth. So this is why my idea, my brain decided to try it with a math channel, because again, it reacts based off of that signal. So again, you can tell our test drive pattern. Let me move the blue down a little bit to get you a better shot. So I was already driving, I decelled and then started accelerating again, and then let off and then started accelerating again once I was already up to speed, you can tell. And then after that, I let off and then just cruised. The reason why I let off, because I wanted to be able to find a point before then as to when I experienced it. So I purposely fully let off and cruised because I experienced the issue beforehand. Obviously, I've got these markers here because, yes, those are points for me to show you and explain. Again, we're using this to look for any anomalies, and if you look towards the bottom, you have like peak there, a peak there, and you have these jagged edge points there. And if let's put a marker there. We'll go here to this first point. Let's see what we find. Okay, so there's our peak that came down, and if we bring this down, it matches up with up here. So we're continuously accelerating and uprising, and we had this sudden dip and then goes back up. That's how I figured, and matches there, that this was probably an area of an issue. And so if we then, I want to look just previous to that point and see if I see anything funky in the signal. And so there's our marker. And if you look, those segments, every 360, 360, 360, 360. And then what do we have here? 2 segment dropouts. Now, one of them is the true 360. It's most likely this one. And we have an extra one. Now, if you remember, how are these created? By missing tooth, missing segment, so on and so forth. So basically, let's call it almost like a loss of the tooth count or the wheel. And so we had that happen there. And then for some reason, we dropped again there. Now, we know it's not a physical tooth creating that because we would see it continuously. And so if we now go down towards the crankshaft sensor signal, actually, let's go back up. We'll mark that point. So let's go right there. Then we'll travel back down. And let's look at our signal there. And there you go. So here is a missing segment. And right here, we have that extra added missing segment that should not be there. So that caused that dropout of crankshaft sensor signal caused that hiccup that we can feel as a driver, a customer, a consumer, whatnot. But then that math channel lets us be able to find it because of an extra dropout of the sensor signal. And so then we just come back down and start looking at the sensor signal. And I know there's different math channels. You can do it with the tooth count one or in set alarms and with voltage levels and so on and so forth. For me, this was my quickest way. I already had math channel already created, set, and I know exactly how to look for what I'm looking, and I'm comfortable looking at this quickly and trying to identify it, which in this case it did work. That dropout, extra dropout, and then the dip in the acceleration of the crankshaft led me down to the bottom of the crankshaft sensor signal, and truly we can truly see that that is the cause right there. Now, of course, if you remember, there was a couple other points that seemed to dip down in the math channel. Let's see if we can find those. Let me back out more. And one thing I did notice while looking at this basically whole waveform, and I don't know if, what kind of play it has with it, but I obviously noticed after finding those dropout points. If you notice this marker, we are right at the point of where that signal messed up. See this clear gap of, I'll call this static, but there's a clear gap there. And see that dip? It's like in that whole time frame where we dipped, lost acceleration, and then we started moving again because clearly we went upwards. So there's that clear gap of static. And if we look up here, there's a dip again. There's another clear gap of static. And here again, let me scroll over to better show you. But look, we got dropout, 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 and then clear static, clear static, clear static. So I thought that was pretty crazy or interesting. Normally try to shy away from getting lost in the woods by following, I'll call it again, static or just noise, whatnot. And so you have to be careful, but when you can back it up with what another true identifiable actual signal and figure, then yeah, then you can find those points. if you look here, and this is why I try to stay away from paying attention to that static or noise. Here, there's a point where it looks like there is a gap, like a gap, gap, gap. But right there towards the bottom, we have small levels of static or noise. So it's not a true, full, clear like these guys. And you can back that up by looking up here. There was never that whole loss of acceleration dip. So that is not a true dropout. And again, there's that little bit of noise, no dropout, but these are. And so again, we can use this. We'll just pick this middle one because we're really just going to see the same thing we saw before. But I just want to show you guys. So we'll go there. We'll zoom in here. And right there, there it is again. So again, Math Channel is helping us. It's showing us, it's telling us the true story of what the crankshaft sensor signal is doing. We scroll down, and then I think you can already see, but we'll do this. So there's our regular gap, let's call it. This is the extra additional gap. And then the next true one is right there. So a true one, additional, another true one there. So again, loss of signal from crankshaft sensor signal. And I'm going to go out on the limb and say it is due to a faulty crankshaft sensor. I have seen this in the past, not just with Mercedes, but with BMW. Kind of very, very similar dropout. With heat, that's the other important thing. Cold, it never acted up. You had to get it hot. And just like the older Mercedes or the BMWs, other ones, again, it's more of a heat thing. The sensor just seemed to break down, stop operating properly, and they'll drop out the signal, cause the car to act up, and then you've got a customer coming through the door telling you to fix the car. So this just helps me verify that we truly do have to replace or sell a crankshaft sensor sensor. And we know we're not going to be throwing parts at it, despite the fact of who knows what was done beforehand. If I don't know if timing was done and the whole time they had a sensor issue, or timing truly was off and then at some point the sensor started acting up. So who knows? But this right here gets us at a point that gives us confidence, and we'll go ahead and replace it. We won't have this issue. We've got to get an OEM one to not put. I'm not going to put any of those. I'll call them aftermarket. I'll get a true, genuine one, install it, clear everything, reset everything, and they should be good to go.